Today's agenda, what we're going to do over the next 60 to 90 minutes, we will do a brief introduction as to who we are, who DoiT are. We have some other guests as well. It's not just me for the entire time, so you'll be delighted to hear that my voice will not be droning on and putting you all to sleep for the entire duration. But I will walk you through the intro, a bit about FinOps and how, when we talk about cost optimization, it's really FinOps that we're applying. So how it works with your business, etc., and generally about costs. So I'll do a little intro on what that looks like, and then a very brief intro from me around compute, and then we dive into some purchasing options by our guest speaker Noah from AWS, who will introduce herself when she comes up. Then after that, I will then do a quick summary of what we covered there. And then we'll dive into containers presented by Lucas, who will do an intro when it's his turn around again. And then to wrap up, we'll cover a little about how we get this information. What's the source of truth for these things? What kind of tools can you use? And then I'll whip through the reference slides. And it really is just a brief introduction to the reference slides. So it's things like you're trying to optimize your RDS or your S3. What specific steps should you be looking at? So rather than leave you not knowing that, I've included all the content from, this is a part of a much larger session where we can dive into a lot deeper. These also form the foundation of cost optimization workshops that we run here at DoiT. So, and then we do a quick summary through all of that. And then what we'll do is, as we go along, if you've got any questions, please ask them in the chat. So our team's sitting here waiting for your questions. You can answer them as they come up in the chat. If you've got specific questions or general ones, and ones that require a bit more of a deep dive, we'll save those for the end. We'll do a quick answer in the chat, and then we'll revert back to them and cover them at the end. So any questions, then please ask them in the chat right now, and I'll press on through the introduction. So DoiT. Who are we and why are we here? So we're a partner of AWS. We also partner with some other cloud operators as well. At this point, all of these numbers just say that we're certainly no last-minute startup. We've been around for a little while. We've been delivering a lot of success to a lot of customers, and we get some really good and strong feedback. We're placed right across EMEA and beyond, and we're a partner premium tier services for AWS, and have a very strong and ongoing relationship with AWS. We have a series of products, some intelligent technology, and our unmatched expertise is, I consider, one of our strongest USPs. So it's the engineers that we have here at DoiT are tenured, strong, and profoundly knowledgeable. That combined with our various technology suites makes what I think is a really good offering. So we can understand what you've got, and we can build for it and help you grow into the future. And so it's simple to start with DoiT. If you're not already one of our customers, then you can just go to our website, doit.com, and sign up today and join up. You simply consolidate your accounts in, and it's all at zero cost to you. So we are funded by AWS to be able to provide this service. This helps AWS scale and grow, and it means that you will never pay more with us than you would do if you were directly with AWS. In fact, I think all, if not the overwhelming majority of our customers end up spending less because they use our tools to be able to do things like save costs. Which brings me smoothly into cost optimization. So what is cost optimization? Now, I'm not going to labor too long over this bit here. Cost optimization is obviously the optimization of costs. But it's about, you start from trying to work out what the costs are critical to your business, and then try to reduce them. Now, I say this often, that if you need to reduce all of your costs, you can just turn everything off and you've saved all of your cloud costs overnight. Absolutely fantastic. But your business will actually stop working. So it's not about cost saving, it's about making more profits. But getting there and trying to pick through what you should be doing is difficult because cloud is complicated. And sometimes you need to have scrutiny over what you're doing, but sometimes you need to have a strong idea of where you're going in order to get there. So you can't just go, we need to save costs. What can we turn off? It's more a question of how can we do things more efficiently? How can we observe what we're doing so that if you make a change, you can then see what the impact of that change is. So there are always opportunities to decrease costs without impacting performance, except they become diminishingly rewarding. So over time, you will do more and more cost savings. It's not a one and done, which I'll cover in a minute. But if you're doing it well, you should get to the point where you're just keeping on top of things as your business grows and matures, as opposed to having to do a big endeavor all the time. It's that standard kind of DevOps agile philosophy. You do a lot, and then you can maintain it. And so we've got a bunch of tools. We have the DoiT Cloud Console, which is a console you can log into. We do a bunch of reportings. It kind of operates very much like Cost Explorer, a handful of additional benefits over it. We can do things like attribution, so you can do easy team allocation of costs, etc. We have our FlexSave product, which I'll cover a little later, which dynamically applies reservations for you without commitment, and giving you the 1 year no upfront benefit. And we have some spot scaling technologies as well to help with your spot usage. We'll cover those a little bit later. But again, to underscore the fact that you get access to all of our engineers and consultancy all at zero cost. So all of those features there at zero cost from DoiT. So I mentioned cost optimization is an ongoing process, and it certainly is. This is a typical cost optimization journey. So the journey begins, spend sits probably too high. There's a cost optimization effort, which then enables and frees up resources for growth. And then you grow further after doing the optimization because everything is more efficient and some of that tech debt's been tightened up, and the costs have been reduced. Unfortunately, it's not so often do I see it as a one-off event, and then it just gets, or it's a cyclic event. They just come back to it once a year. That's not the ideal way to do cost optimization, which brings us into FinOps. So what is FinOps, and why are we talking about this? So FinOps is financial operations in the same way that DevOps is developer operations, but it doesn't really encapsulate it. I mean, what does encapsulate it is, I like to say that you just turn it off when you can, make it the right size so you're not wasting resources. If you can't, just turn it off, and then apply some kind of commercial construct like reservations or use FlexSave after that. So that if you remember nothing else from today, if you remember this, then you'll be in a better place than when we started. Questions in the chat as we go along. Please let us know you're still there. I'm talking to an illuminated light at the top of my screen at the moment, and I hope there's still an audience out there. So it says that 68 people are paying attention. I hope that's true. So the source of the issue, this is from the FinOps Foundation. So if you go to finops.org, it will tell you a lot more about FinOps. It encapsulates everything I've learned over the last 10 to 15 years of working in this industry and helping customers save money. So the source of the issue is, again, I'm not going to cover this. I'll just touch upon some of these points. You end up with you're using the wrong resources. So the number of times I see you've got your long-term storage of stuff in S3, and you're not storing it out to Glacier. There's a lack of automation. So every single time a person needs to spin up some infrastructure, they're doing the same basic steps. These kinds of things can all save a lot of money. And they're all covered by the FinOps approach. And things like development approach, are you working on an old school kind of cascade waterfall model, etc. All of these apply, and we can go into a lot more depth on these. I'm not going to here. This is not FinOps per se. We do have a separate FinOps session that we ran last year, and we plan to run again this year. But this is an introduction to FinOps. Which, as it says here, is a new discipline focused on cross-functional collaboration to control, predict, and manage cloud costs. And I've left that direct quote here because that's as succinctly as I can put it. It's broken down into 3 core segments, ways of viewing it. So you have visibility, so you can see what's happening. You have governance, so you can control it. And then you have the cost optimization, which is the actual process and implementation of some of those philosophies. So again, FinOps is not about saving money. It's about making money. So as I say, if you want to save money, just stop spending. Just turn everything off, and you'll definitely be saving money at that moment. But you're no longer a business because you're not going to be generating any money. So it's not about cutting your costs purely. It's about generating more profit. FinOps is focused on the business metrics. If you focus on your pure cost as the number, so if you're spending $100 today and you wanted to get it to $50 tomorrow, what are you going to lose? Because it could be that you're at peak efficiency already. You're better off looking at a business metric such as what's the throughput of daily users, and how can we optimize that what's the cost of a daily user, and how can we make that cost smaller. That will drive you so that your business is still functioning, but your costs are being more optimal. And fixed versus elastic costs, of course, a lot of the time in a data center, you would just spin up some infrastructure and leave it. In the cloud, it can be flexible. A lot of the time, people forget that and don't apply that flexibility. So here's a very brief overview of the inform, optimize, operate cycle. So you have some visibility from inform. That in optimize can be reserved instances, right sizing, applying the automation, etc. And the operate phase here. This is your culture. You've got to have a blameless culture. You've got to have that kind of approach. If you don't, then it makes it very difficult, because when it turns out that somebody spun up a workload and left it running, they're not going to admit that. They're going to try and correct for it, but it means that you don't get to correct for it in the future, because there should be a guardrail around that. That's how you apply true governance. And then you get faster speed of delivery, and of course you get much more value to the business. So as I said, I'll repeat this. So these slides are not to be read out in detail. We don't have time for that today, but they are to be looked at again later if you want to absorb some of that detail. But so as a reference slide, I've included this again. So it highlights that in the inform phase, we're looking at things like dashboards and reporting. And then later on, you're looking at terminating some of the idle resources. Be careful with that. Remember, average CPU over the course of a minute may mean that it was 100% CPU for the first 30 seconds and then 0 for the rest of it. And that will look like 50% utilization, but it's not. It's clearly hitting 100%. So you've got to look at your peaks and troughs. And operate is about continuous improvement, about the business being aligned and all talking to each other using a common vocabulary. That's the core thing for me. FinOps is about common vocabulary. You have access to Cost Explorer from AWS, which has grown significantly over the last few years. In my 5.5 years when I was at Amazon, I found it an interesting tool initially, and then it turned into a very powerful tool for controlling. So you do have cost control through Cost Explorer, and there's various ways of doing that. If you want to know more about that, then Noah can go into great depth on this. So AWS is always there to help support. If you've got any specific questions around that, please ask them in the chat now, and then we'll cover them. We provide our own DoiT Cloud Console, which is, it presents a similar sort of information that you're seeing from Cost Explorer, except it profiles it in a different way and allows some it's additional data. It allows you to profile the business in a very different way. So just to wrap up on this, we've got cost allocation, making sure that everybody is accountable for cost allocation. That's super important. So finance are using the data to do chargebacks, for example. Operations are breaking down to make sure they're doing the correct budget tracking. Cost allocation is a core fundamental part of FinOps. This is where I start the conversation with all customers. And if you want to know more about FinOps, or want to go into greater depth, then I can bore you over a coffee anytime. So please let me know. So the core principles of FinOps, covering them just briefly, is teams need to collaborate, to work together to try and help reduce these costs, because it's about that profitability. You want to make sure that ownership is taken for their cloud usage. You don't want people just spinning up stuff and forgetting about it because that's finance's problem. And a centralized team often helps when it comes to FinOps. And then the rest of this slide is around the value to the business and being able to get that reporting. So all of that said, there's a lot been said around FinOps. I see no questions. This is amazing. I know I'm talking fast today, but and hopefully you can hear at least some of what I'm saying. Now, this is recorded, so you can play it back at 50% speed later and then listen to me at normal speed. But of course, hopefully you got some questions. If you have, if the question is, what have you been saying for the last 20 minutes, Ian? That's fine. I won't take offense, I promise. But what makes up most of my customers' bills is compute. And there's a very good reason. So we see across the industry, 50 to 80% of cloud bills taken up by compute. So there are ways of trying to mitigate this. I see things like reservations as a kind of a sticky plaster, because it's a way of reducing the cost for a bit, but normally they're time limited and they're less impactful than infrastructure changes. But you can apply these reservations as needed. So I referred also earlier about saying these slides for reference. So when it comes to compute, what can you do to get that cost down, given that's such a big chunk of the bill? And so here is the what I call the 4-box slides that will feature quite a lot later on. So the analyze, decommission, right size, and discount is kind of that 4-box format is something that we'll follow through. And it's about we can look at, so here we would say, okay, you look at the price in Cost Explorer, for example. That's a way of doing it. Tagging, please tag your resources. If you're not tagging today, you should be. And it's because you can't really have a strong conversation about cost optimization and profit increasing without knowing what you're doing. And that starts with tagging, knowing what the resources are. You decommissioning, removed unused instances. That's pretty much a no-brainer, but you'd be surprised how many there are just laying around quite often. Using things like instant scheduler to turn stuff off overnight. That's really important. And when it comes to right sizing, auto scaling, flexibility of workloads, every single AWS cloud presentation out there talks about the elasticity of the cloud and embracing that. Make sure you've got the correct instance types. So did you know that you can use a T3? And a T3 is a burstable, relatively low cost instance that can very often replace your M series. So you've got big workloads that could be replaced by T series, for example. So that comes up quite often still. You can use Lambda, Fargate instead of the instances. So containers is always a way to go. Serverless is very, very cost effective for certain use cases. You've got different, very different ways of that. We'll dive into this a little bit more detail in a second. Noah will dive into some of this stuff around things like discounts, so spot instances, savings plans, etc. We'll dive into that in a bit more depth. So that said, I will now hand you over to the delightful Noah. So Noah, if you'd like to start sharing your screen, please.
Yes.
I'll disconnect here and hand over to you.
Okay,
I see your questions in the chat, people, and I will be answering them as Noah is delivering her part of the presentation. And again, if you've got any additional questions, please post them all into the chat. We'll collect them and answer them at the end if we don't get time. Over to you, Noah.
Thank you. So my name is Noah. I'm from AWS. I'm a customer optimization and enablement. We help customers to optimize their workload and save money in AWS. So today we're going to focus on how to leverage saving plans and reserve instances. We're going to focus on the compute. And we're going to go over how to leverage AWS pricing model, how to purchase, manage, and monitor our saving plans, and to set up alerts that can save us money. So before we begin, we want to make sure that we are in the right place. If we are looking at our workload, what is good look like? So on the left graph, you can see that it's before we did some cost optimization, and I'm gonna walk you through how we do cost optimization. So we can see that our usage is growing, increasing, and our cost in orange is also increasing in the same ratio. But if we're doing some process for cost optimization, we are expecting to be here in the right graph to see our usage increasing, but our cost not increasing in the same ratio. And how we can get from the right to from the left to the right, we're going to find out now. So we have a lot of ways to do cost optimization. Ian talked about some of them, like right sizing, modernization. It's the more technical. Today I'm going to focus about AWS pricing model. And in order for us to start saving money, we need to know what we are being charged for. And we need to know AWS pricing model. So the first thing is pay as you go. It's exactly like it sounds. We pay only for what we are using. For example, just like in the electricity, if we turn on our light in our home, we're going to pay for it. But if I leave the home and turn off my light, I'm not going to pay for it. Same here in AWS, you only pay for what you use. The second thing is you pay less by using more. We have services that if you are using it more, like S3, our storage services, if you are using more gigabytes, you're going to pay less. So it's really important to know for each services you're using, how you're being charged for. And the last thing, and this is the focus today in my session, is save when you commit. We have the option to commit for a specific amount of spend, and in return, we're going to get a discount. It's just like if I'm going to Pilates classes, and if I'm going to go for each class separately, I'm going to pay $10 for each class. But if I buy a ticket for 10 classes ahead, I'm gonna pay less for this ticket, and eventually each class gonna cost me less the same year. So we're gonna focus on the pricing model of compute. This is our main focus today. So the first option we have is on demand. We talked about this as the pay-as-you-go. We only pay for what we are using, and it's really fit for unexpected workload. For example, if I have a new project and I can predict how much I'm gonna need, I need the flexibility to turn on machine and turn off machine when I need to. So if I have unexpected workload, I'm gonna use on-demand pricing model. The second thing, it's spot instances. It's easy to spare capacity, and it can save you up to 90% compared to on-demand pricing. I can give you the following scenario in order for us to better understand what is spot instances. So let's say AWS has 10 machines, and 8 of them are rented for customers that are paying on-demand rate. They are left with 2 machines, and they are coming to you and saying, hey, we have 2 machines, and you can get those machines in lower prices, but if another customer will want those machines and will be willing to pay on-demand prices, then you will get a notified 2 minutes before, and within 2 minutes, you're gonna give me back the machines. So it sounds not a lot of time to handle this situation in 2 minutes, but we have a lot of strategy. We're not gonna get into it today to manage this situation of the 2 minutes notice. It doesn't happen a lot, but we need to prepare and to know which workloads are gonna fit for this scenario. So we're gonna use spot instances for a workload that can be interrupted. For example, if I train in my machine learning and it's not customer facing, I can use spot. And the last thing, the main focus today, it's saving plans and reserve instances. This is our 2 options for doing commitment in return of getting discount. We can save up to 72% compared to our on-demand rate, and we can commit to 1 year or 3 years. So if we have a workload that is expected and steady, we can commit and in return get a discount. So the magic in cost optimization in pricing model in compute is the combination. So I'm expecting to see for the first layer of my steady workload, saving plans ORI. After that, the second layer, I'm expecting to be on demand for the spike workload that I can predict, and to use spot for the workload that I can tolerance interruption. And if I maximize all of the pricing model, I can maximize my saving in AWS. So let's focus on commitment. So let's say that I have expected workload and steady workload, and I want to commit. How will I know? What is the commitment I can make? What is the saving it will give me? So we have a tool, and Ian talked about Cost Explorer before. We have a tool that can help us decide and make a decision based on our past workload. So we can decide to see the recommendation based on the past 30 days, 60 days, 7 days, and play with the saving plans terms. For example, if I want to commit for 1 year, 3 years, of course that if I commit to 3 years, I'm gonna get more discount. And play with the payment option. I have all upfront, no upfront. And in this tool, I can see how much I'm paying on demand rate, how much I'm gonna pay in saving plans rate, and how much I'm gonna save. And what is the commitment that I can make. So the recommendation is only a recommendation. You can decide to take a conservative approach and to commit to less when you purchase your saving plans, but it's really good starting point to use this tool in order for you to see and to plan and to estimate if you have a recommendation and how much you can commit to. And we talked about saving plans and in compute. I'm not gonna get into this today, but just so you know, you have the option to make a commitment and get a discount for other services other than compute by purchasing reserve instances. It can apply to RDS, Redshift, Elasticcache, OpenSearch, DynamoDB. It's less flexible, but it still can save you a lot of money for those services. So we went over our AWS pricing model. We decided to purchase commitment of saving plans. And now what we're going to do, how we can track and manage it. So we don't just purchase saving plans and then forget about it. We need to track this. So we have all kinds of tools in AWS that will allow us to do it. So we have an inventory tool, utilization, coverage report. I'm going to go over this with you in a moment. And in addition, I want to set up alerts that will enable me to know when my saving plans expire. I don't want to find out in a year that, for instance, my saving plans expired and my cost really increased, and then to find out that I didn't know that my saving plans ended and I could have saved more money by purchasing it. So I want to plan this by setting up alerts. And another thing is to set up budget in order for us to set up thresholds for coverage and utilization. So let's begin with the first one. It's the inventory. So after a purchase, how do I know how much I have, how much saving plans I have, when they end? So I have the inventory. It's an overview of all the saving plans I have. I can see the saving plans ID, the status if it's active, retired, the type. I have all kinds of saving plans type I can purchase. I can see the commitment I made, the start date and the end date, and I can download it to CSV and analyze it. The second thing is the utilization report. So the utilization report show us the percentage of how much we are utilize our saving plans. So we have the overview of the saving plans that we spend for the time period we chose, the on-demand spend that we would have paid if we would not purchase the saving plans, and the total saving we made in the time period I choose. So this one is a report that can show me trends of my utilization of my saving plans over time. I can set up a target. For example, here I set up 100% of utilization, and I can see the actual utilization of my saving plans if I actually using all of my saving plans commitment. Because if I'm not, maybe I want to plan it in a different way. I can see it monthly, hourly, daily, and download it to CSV. And another report that can show me trends over time is the coverage report. The coverage report is showing me the coverage, how much of my workload is covered by saving plans. And here I can see the potential savings, and I can set up a target too, just like we did in the utilization report. In here, for example, I want 80% of my workload to be covered by saving plans. And like you see here, I'm below it. I'm on 20% covered, below 20%. And in here, if I see this report, maybe I can see that this is time for me to purchase more saving plans in order for me to cover more of my workload with saving plans. So it's really nice tools in order for you to track and to see the trend over time. But if you want to be notified for things and plan ahead, we have all kinds of alerts that will enable you to manage it. So the first thing is manage the expiring saving plans alerts. So you can get alert when your saving plans expired. You can decide if you want to see it 1 day, 7 days before, 30 days before, 60 days before, and enter your email. That way, by the end of 1 year or 3 years, depends how much you decided to commit to, you can know before that your saving plans going to be expired, and then planned according to this how much saving plans you need to purchase. Another alerts that we have is the budget alerts. We went over before the utilization report and the coverage report, but it's all showing me the trend of the time period I chose. But if I want to get notified and set up threshold, for example, if I want to know once I'm under 100% of my utilization, so I have this option in my budget alerts. I have for saving plans and reservation. And for example, here you can see that if I'm choosing to set up alert for utilization, so the utilization will measure if there are unused or unutilized saving plans. And I can see the recommendation based on the last month and set up my threshold and get alert once I get under this utilization. So what are the key takeaways with this very short session we have now? So the first of all, we went over our pricing model. In order for us to even start doing cost optimization, we need to know what we are being charged for. So we need to know, to get familiar with AWS pricing models and all the options we have. Another thing is after we purchase a commitment, we want to measure and monitor our commitment by using AWS tools. And the last thing is to set up alerts that will enable us to track, plan ahead, and to avoid unpleasant surprise by the end of the month. Thank you. So Ian, back to you.
Thank you very much indeed, Noah. And so, as I say, any questions? Raise them in the chat. And so it was a super brief. This is only introductory, and so it's but thanks very much. I think we've got at least one person in the audience that has learned something from that. So it's to look at some utilization reports for savings plans reservations. So they're useful, and yeah. So I'll cover with a quick summary of what you went over there, just to highlight it in 15 seconds or less. So you've got multiple ways of buying compute, for example. So you've got on demand, you've got saving plans and reservations, and you've got spot. I'll cover spot in a second. So don't just stick with your on demand. If all your workloads are on demand right now, then you're essentially leaving money on the table. You can make that more optimum. So it's universally true that all the cloud vendors will trade commitment for discounts. Remember that and apply accordingly. So here we're talking about, you know what, I'm going to be using this resource for 12 months. So I'm going to commit to using it for 12 months. And therefore you'll get a reservation discount from AWS. Also remember that there are multiple, thank you, Christoph. Yeah, there are multiple, you've got reservation, your RIs, you've got convertible RIs, and I'll cover that in a second as well. There's lots of them, which can be a challenge in and of itself. But there's also different, so for any one lot of compute, you've got Intel, you've got AMD, and you've got Graviton. Currently today, who knows what's around the corner? And these are different chip silicons that it runs on inside Amazon. So if your workload is like a Java workload, it's ideal to pull over onto Graviton because it's fairly agnostic as to what the underlying architecture is. Always test, always test, please, before making heavy changes. But you'll find that AMD can be a bit cheaper, and Graviton can be cheaper again. Also, they use less energy. So if, like me, you're interested in making sure the world is still here tomorrow, then using less energy is a good thing. So not is it more cost effective, it's actually slightly better for the planet. So, and when that scales up, it makes a heck of a difference. So on Graviton, you will find that overall, it's generally a much more competitive price. There's a wide range of different models available to be able to suit your particular use case. I'm not going to dive into this slide. I'll leave it as a reference. But just if you haven't heard of Graviton before, go look it up, have a look, see if your compute workloads that are running today can be applied and run on Graviton, because it could save you a lot of money. It's not universally available everywhere inside. So sometimes you want a particular instance type, and it's not going to be inside one particular region. But of course, you can always use it inside an alternate region. And AWS has a huge amount of instances just sitting there, ready for you to click the button or to run your Terraforms or CloudFormations and start using them. And that spare resources, it just sits there waiting to be used. And so rather than be sitting there just warming up the planet, it's available at a discount, and that's where Spot comes in. So you can sometimes find that you can get like up to 80% savings, more if you're very well blessed. So if you've got a Linux workload of a particular size. So Spot is very much worth looking at. It is impactful. So you get about 120 seconds worth of notice, and it can be taken away because a person wanting to use on demand now needs to use that, because Spot is the reserve capacity of AWS. You can set up things like I've shown here on the screenshot. You can mix and match. So you can have, we want a core 10% of on demand and the rest of it's Spot, just in case there's no Spot available. So if there's no spare capacity for that particular instance. But when it comes to using spare capacity, you want to make sure that you're taking advantage of the fact that there's more available elsewhere. So you might need an M5 to run your particular workload, but it could also run on M4, or even if there are still some in that region, M3s. Or one of my customers still running an M1, and so I think just one now. But I keep telling them, please update. You're leaving money on the table. But so diversification is super key when it comes to using Spot. Spot is a whole nother rabbit hole which I could dive into for hours. But essentially, Spot exists. It's the reserve capacity for AWS. They want you to use it because then it means that it's not just sitting there just being warm. But diversification is really, really powerful. So think about which availability zones, which regions it's in, what kind of instance type it is in and of itself. So if you've got a workload which doesn't really mind what it's running on, then you've probably got a workload that's going to be very useful for a Spot. So Christoph called out there in the chat the reserved instances and convertible RIs. And of course, there is a wealth of different variables. So I've highlighted them on this screen. You can see there's like from your commitment length to the scope, to the platform, to the service, to flexibility. There's a huge amount of detail that you can apply around reservations. I will say this, do something and do it quickly. If you think you're going to be using your resource for the next 7 to 8 months, which is the ROI of a typical reservation for a 12-month reservation, then do it sooner rather than later. Otherwise, you essentially just letting money burn when you could be saving some extra costs. And they're not insignificant. It's at least 10% in most cases. So, but that said, it can be very complicated. So because we saw the complexity of the reservations, saw that many customers suffer from analysis paralysis, where you don't know what to do. So you end up doing nothing, which means you're by default just spending more money. And if you've got money to give away, then, hey, you know what? I've got a PayPal. Please send it over. But seriously, if you're not able to make the reservation decisions, then fear not. If you're with DoiT, then you can take advantage of our FlexSave product. So our FlexSave product, it uses a machine learning algorithm to identify what your workloads are doing on an ongoing basis, and dynamically applies reservations that we've purchased. So we bulk buy the best price available, a bunch of reservation savings plans, and we'll dynamically apply them to your infrastructure for you at zero cost. We do that because we share with you the 1 year no upfront benefit of those reservations. So this is what it sort of looks like. So we're continuously analyzing it, and we're looking to see the gap. You can see you can still buy your own reservations with FlexSave, and we just cover the residual gap. So you end up, and you can still use Spot as well. That's not covered by FlexSave or reservations because, of course, it's already incredibly cost effective. But you can see that FlexSave can be very powerful. And equally, we also have another product because we looked at Spot and went, you know what, a lot of customers struggle moving some of their more on-demand workloads across to Spot. So we have Spot scaling, which can help you shift that workload over. We've got a couple of really strong references that we've just been working with that have used this very, very effectively indeed. So with minimal impact to their actual infrastructure and zero impact to their business, they have managed to reduce costs, kind of what you see on the graph here. So there's Spot scaling as well. Now we'll talk a little bit. Spoken a bit about containers, a bit about the reservations, etc. And we've lightly touched upon a bunch of topics. What we've not really gone into here is containers. So I will hand you over to Lucas, who will talk a little bit about what cost optimization on containers looks like, and hopefully lift the veil off of that mystery. Over to you, Lucas.
Splendid. Thank you, Ian. My name is Lucas. I'm a cloud architect at DoiT International, and one of the core areas of my work is container technology, and specifically Kubernetes, and helping our customers get a good bang for their buck when using AWS and the managed Kubernetes service. Like Ian said, it's 2023, and for better or worse, containers are kind of popular. So this has certain implications when it comes to accurately tracking and attributing costs for your workloads, for your teams, for your tenants on your clusters. When using the Elastic Kubernetes service to orchestrate container workloads on AWS, platform teams are facing some additional challenges. First of all, implementing AWS tags on your EC2 instances, on your auto-scaling groups, on your networks and so on consistently is already difficult. However, Kubernetes adds an additional layer of abstraction on top and lends itself well to running elastic, short-lived workloads that share the underlying EC2 infrastructure. So there is no clear one-to-one mapping between an application and an EC2 instance or a group of EC2 instances anymore. Therefore, a common method that platform teams often use to enable cost allocation within their clusters is sharing a cluster in which each tenant gets its own dedicated node group. They can then use Kubernetes features like node selectors or node affinity to instruct the Kubernetes scheduler to run one tenant's workload or one application on a dedicated group of EC2 instances. Those EC2 instances can then be tagged with an identifier like the name of the product, of the team, of the tenant, and you can use those tags to allocate costs. However, there is a downside to this approach. You may end up with a lot of unused capacity in each node group. You may need to manage a large amount of separate, distinct node groups, and you may not fully utilize the potential for cost savings that come with running a densely packed cluster. This was a question that Oliver posted in the chat earlier. I assume that this is referring to EKS, Kubernetes clusters. A larger cluster always gives you more headroom for efficient bin packing and for utilizing the compute resources underneath more efficiently. Also, with this method, using one group of EC2 instances per team, per application, you still need to manually allocate the cost of shared resources that are existing outside of Kubernetes, like the control plane, your Kubernetes masters, databases, shared load balancers, log collection, monitoring, and so on. Another pattern that I commonly see used by operations teams in the wild is to segregate their Kubernetes clusters into separate namespaces. So while customers can accurately track their costs for the control plane and the node groups, they likely need deeper insight into what is happening inside the cluster in order to accurately track their costs on a resource level. This is where Kubernetes namespaces or logical grouping of resources within Kubernetes can come in and can help, reflecting the same organizational concepts: a team, an application, a tenant, or a customer. There seems to be, let me know in case more people cannot see the presentation. Livestorm, the tool that we're using here, seems to have some technical difficulties here. I'll elaborate a bit on spot scaling for EKS afterwards in our Q&A session. I'll circle back to Musa's question. So once you have segregated your classes into namespaces, calculating the costs by workload or namespace is a challenging task. To determine the resources used by a group of pods, you have to aggregate the compute resource usage, used or reserved CPU resources, memory, disk for a given period. But due to the nature of container workloads, they are generally short-lived and may scale frequently up and down, depending on the number of active users, depending on the load coming in, and the actual resource usage fluctuates a lot over time. In other words, you cannot simply take a day's usage of your application and multiply it by 30 to estimate the monthly bill. You're going to be off by quite a lot here. Understanding the cost responsibility of a workload requires aggregating all of this over a month, or over the reserved, or over the time frame that you want to look at, and then evaluating the charges based on the actual cost and the duration. When using this segregation into namespace-based attribution, out of cluster costs that I mentioned earlier, like a load balancer, a shared database, an S3 bucket, are often broken down and attributed based on how hungry an application is in terms of resources. So an application that consumes more compute or memory often gets attributed with a larger share of the database costs, of load balancing, or of traffic. However, this is at best an estimation and not an accurate attribution. This is why a company called KubeCost has identified this as a niche and has released a product to tackle exactly this. KubeCost is built on the open source project OpenCost, which was also recently accepted as a Cloud Native Computing Foundation project, and is actively supported by AWS as EKS add-on. It can be installed with a single Helm chart, with a single Helm install command, and is actively tested and maintained both by KubeCost as well as folks at AWS. It builds around widely used cloud native technology like Prometheus for metrics collection, Kube state metrics, node exporter, Linux connection metrics, and so on. Following multi-tenancy best practices, you can then create a namespace for each tenant and use KubeCost to determine each tenant or namespace's cost responsibility. It allows you to drill down by service, deployment, namespace, labels, and so on. It also allows you to track the spend by tenants without creating separate clusters or separating workloads by worker nodes. So separate EC2 instances or auto-scaling groups underneath. It provides an easy to implement and cost-effective way to perform chargebacks or showbacks in multi-tenant Kubernetes clusters. In order to make this an accurate attribution and not just an estimation, KubeCost is able to ingest the AWS cost and usage report. Some of you might be familiar with it from S3 in order to factor in discounts like enterprise development plans, savings plans, and form the missing link between AWS resource tags, so tags on your EC2 instances, on your networks, and Kubernetes labels. It basically forms the glue between those two sets of labels. It then allows users to correlate in-cluster costs with out-of-cluster costs in an accurate way. Since you might not only be using on-demand or reserved instances, what KubeCost also does is it ingests the EC2 spot market price feed in order to report accurate point-in-time costs, because the cost for spot instances can fluctuate quite a bit over the course of a day or a week. KubeCost will show you the accurate cost of running your app at this particular point in time if it was using Spot. If you deploy KubeCost out of the box, this is what you will get basically, an allocation broken down on a per namespace basis, and out of the box KubeCost retains 15 days of metrics. This is the free version of KubeCost, doesn't cost anything. If you would like to get automated recommendations or automated application right sizing, there is also a paid enterprise version of KubeCost, which then allows you to automatically resize your workloads in order to be more cost efficient without a human needing to implement those recommendations. So as for better or worse, Kubernetes is very popular and a lot of our customers are using it. We have developed a bit of a framework or a roadmap when it comes to Kubernetes cost optimization. Those are basically the questions we ask and the topics we go through with our customers if they approach us wanting to get a better bang for their buck for Kubernetes. You can't improve what you don't measure is very true also for applications on Kubernetes. While AWS provides a solid set of metrics and tools for observability, often custom instrumentation of application code is required to get deep insight into what's going on inside of your services, your microservice landscape. This is also where tools like KubeCost come in and allow cluster operators to get additional visibility and to tie together metrics collected inside of your clusters with cloud provider pricing. Okay, I think the screen share should be working. Like, let me know in case there's still some technical hiccups. A large chunk of Kubernetes workloads that we see in the wild get deployed once with very generous resource requests. Basically, that make sure that nothing blows up and that you don't run into out of memory situations. Also, because humans are really fond of round numbers, assigning 2, 3, 4 CPU cores, 2, 3, 4 gigabytes of memory to an application. But often those resource requests never get adjusted again. Making sure that they match real-world requirements of your application pods is crucial to achieving good utilization. This also then allows Kubernetes to do efficient bin packing of your workloads and utilize the underlying EC2 instances that you have to pay for as good as possible. Elasticity and automatically scaling your applications up and down based on certain parameters, whether that's CPU load, number of active users, processing backlog in a queue, then unlocks additional savings potential. A lot of companies or teams have a very spiky workload, whether this is over the day, over the course of a week, or seasonally like Christmas or Black Friday. And leveraging Kubernetes built-in features for auto-scaling allows them to increase the size of the clusters when they actually need it, and then shrink them down again once demand goes down. Once all of this is dialed in, we then leverage different purchasing modes that Ian referred to earlier, whether that's savings plans or reserved instances, spot instances for interruptible workloads, or using DoiT's FlexSave to automate savings plans management. This is then usually the last piece of the puzzle to keep costs for clusters in check. I'll circle back to the questions in the chat and hand back to Ian now.
Excellent. Thanks very much indeed, Lucas. Yeah, there's a handful of questions, so you should be able to answer them far better than I, and hopefully that was good for everybody. Moving on from containers, compute, etc. One of the questions I sometimes encounter is, how do we see where do you get this information from? How do we do this ourselves? So I've included a section here on tooling. So again, super brief intro, but there's a tool inside AWS, or a way that they capture all of your cost and usage is through a cost and usage report. That cost and usage report is available through your console, and you can get that and set it up if you don't already have access to it today. It's normally a lot of data, but you can bring it in, you can crunch it through Athena, Redshift or whatever, or you can kind of export it out to other tools for then some additional like QuickSight, etc. for analysis. We use that data, the CUR data, we ingest that into our DoiT console as a part of our product, and FlexSave uses that information to monitor your usage, and based off of your changing workloads, it then reacts and applies dynamically the various reservations. And so we know it's highly effective because we're using it in a very highly effective manner. You can use it yourself. I used to work I worked at AWS before joining DoiT, and I used as a technical account manager there, and I used to help lots of customers apply various different types of technologies that are available through enterprise support to help them build their own tooling, essentially. Now, in AWS language, that's called undifferentiated heavy lifting. I wouldn't recommend building your own tool unless you really need it, because you've got very specific requirements, such as those driven by Netflix, etc. And I think Capital One did a very good open source tool as well that they made available. So it's available out there, and you can use open source tools. You can build your own, or you can use off the shelf ones from partners such as like DoiT or the marketplace. But ultimately, everything is source of truth from the CUR, the cost and usage report, and that's both a positive and a positive benefit and a challenge at times, because the rate at which the services drop information into the CUR, the cost and usage report, is not consistent at all times. So some services drop in very, very quickly. Some services can take up to 24 or 48 hours to appear there. So that's a universal challenge. We're all restricted by that. And so sometimes you'll make a cost saving and you'll be like, hey, I want to see what this impact of this is. If you're unlucky to have chosen that on one of the services that has a long delay on it, it can take a couple of days to really see that impact. So try to be mindful of that, and so you should be using other metrics as well, like those coming through the various other metrics that are driving your business. So you're looking at real-time usage, etc., and looking to see if you can minimize that. This is why that's why it harkens back to the FinOps piece of identify a good business metric and then work out what the cost drivers are for that. Come up with a formula to see what that business metric looks like in cost terms, so then you can improve that metric, and then you're saving costs without negatively impacting your business. So it's always driving towards that common improvement. So you can use Cost Explorer, you can use QuickSight, as I mentioned, you can use any other tool that you like to be able to draw that information out. As I say, the DoiT console is a very powerful tool, and we do things like we use that data for anomaly detection, so real-time anomaly detection. So you do nothing, you just call it out. You can set very specific attributions, so you can consolidate resources together, so it then detects and monitors those. You can do call-outs, alerts off of those. It's a very powerful tool and fairly accessible to use. Fortunately, when you're onboarded into DoiT, we give you a quick intro as to what it is, and our help is surprisingly good. So onto the service specifics. So we talked a bit about compute, and we talked a bit about containers. And we talked in general terms about like reservations, etc. But what if you've got EBS that you've identified that, you know what, we're spending a lot of time and money on the EBS and snapshots. A quick call out on snapshots. It could have a GDPR impact. So sometimes the cost is not the cost of the actual money of storing these things. It's if you've got data which is sitting there, which inadvertently violates your own data policy. So we retain data for 6 months, for example, but you've got snapshots which are 9 months old and they contain some of that data inside those snapshots. Technically, you're in violation. So be mindful of that, of course. But there are lots of things you can do. And so this is the first of a series of slides that I'll just very briefly introduce you to. And so you can see what the analyzed, decommissioned, right-size discount looks like for a specific service. So if you've got, hey, I need to right-size some network, this is what that can look like. It's always much more complicated than a bullet point. But so when it comes to network, like VPC flow logs, I'll put an asterisk on that and I'll call it out. VPC flow logs track the end-to-end location for each network connection that you're monitoring. It can generate a lot of data very, very quickly. So you can use it for a quick analysis to make sure you haven't got any fouled routes which are causing excess latency or excess cost by intra-region routing. Or sometimes, in one case, we turned on flow logs and saw that the data was being routed to an old data center and then back up again because of the initial routing was done for a test and it was never removed. And they were running like that for 9 months. So it was very, very costly because all data out of AWS has an egress cost, which can be mitigated in various different ways, but still, it's and always think about with all of this stuff, it's not necessarily the dollar cost, it's about the risk cost as well. So think about if you haven't got, for example, any DR or HA, then think about what happens if your business disappears because the systems fail. So think about in those costs. But say you want to optimize S3, here's some quick tips around how to look at S3 and ways of trying to minimize costs there. Databases is a huge topic, one that continues to grow year on year with each reinvent. But again, and I'll call out again Noah's comment around the reservations. It's not just compute that can benefit from reservations. It's certainly the biggest compute, but RDS, Elasticache, etc. There are lots of other services out there that have reservations for them. So I'll leave those slides. They'll be in the pack that will circulate after this. So you have to look at those in a bit more detail. I just want to cover, as we come up to Q&A time, I want to make sure that we talk about the well-architected framework. So this is oft ignored. Well-architected framework is inside your console. You can just go, it asks you a series of questions. This is comparing your workload based off of your questions and analysis to the best practices available from AWS. So AWS has millions of customers, and they've said, you know what, these things tend to lead to success over some others. And so they've baked those into the best practices, made them available to you. There is a cost optimization pillar, which has some excellent advice on it, and it should underscore everything and echo everything we've said today. There's also a sustainability pillar. So it's making sure that we have a world for our children to occupy well. So there's a sustainability piece to make sure you can, if you make your workloads more energy efficient, they're going to be more cost effective as well. So that ties in quite nicely. But never neglect things like security and reliability, because that's impacts to your business, which doesn't have a dollar cost right now, but it absolutely does. Ask anybody who's suffered from a breach or some prolonged downtime, and they'll tell you what the actual tangible dollar cost was for that. So be mindful of that. It always feels like a grudge buy when it happens early on, because you're essentially, it's like an insurance. You're buying reliability in case something happens, and surely it's in AWS's best interests to stay up and to maintain uptime. But of course it is, and the uptime of AWS is very, very, very good. But it's not universally impeccable, because every now and again a comms provider will dig up a road and take an entire data center offline. So you want to have some kind of resilience there. So well-architected framework will help you analyze your workloads in comparison to the best practices. And at worst case, it just fills up your backlog and never gets attention. Best case, actually saves you money, and it gives you some areas to look at. So please give it a look. It's often overlooked. So someone asked in the chat earlier, what does good look like for FinOps? And it honestly is one of those answers I have to say, it depends. It depends on what size company you are, what your maturity is, what your approach model, what your delivery model, what your ways of working are. It's a very complicated question. So as a technical account manager, I would typically get to understand my customer, identify how they operate, and then when they ask me this question, I can tell them what's probably likely to be best for them. So I'm not a fan of giving generic advice of, well, normally you just want to make sure you've got goodwill and trust across the organization. That is true. But if I know you as a customer, I'll tell you why you need it, who needs it, which departments are going to have it, and honestly, how to go about doing that potentially. I highlighted earlier as well that reduction in cloud waste, it will lower costs. I touched upon it briefly, and I highlighted that, you know what, you want to save money, just turn everything off. And so a reminder, cost optimization isn't about turning stuff off. It's about making things more effective and efficient so that you are more profitable as a business. Breaking down of departmental silos, it's super common. There is clearly a part of the human condition that means that working inside sub-silos is somehow more effective for us. It's just we tend to work with our tribe, with our team. Breaking down those departmental silos, so the typical developer versus ops, or the sales throw it over the wall so that support can look after it, or it's these are silos. Breaking them down, having everybody talk to each other, that's a fundamental core of FinOps. And some of the stuff you'll find there, if you go to finops.org, you'll be able to find more information on how to go about doing that. Once you've freed up some cash and made some more profits, you'll find that the acceleration and innovation takes care of itself, because people are more focused on, rather than taking care of just keeping the lights on, people now have time. It frees up time, frees up resource, frees up money for investment into business growth. It drives accountability and auditability. So making sure that people are being held accountable if they are overspending. And overspending, of course, is a dangerous term, because you could have set an arbitrary budget last year, but things have now changed. So stay agile, stay focused, concentrate on the business metrics. Is your business performing in the right way? And identifying that is a insidiously difficult question. I'm not going to lie to you, it's very hard to come up with a good business metric that is optimizable. But once you've got it, you can then double down on that. So accountability, auditability, that's, you have to monitor stuff before you can improve it. And finally, when it comes to bill shock, we've all seen these the fear online sometimes is that, oh, I've spun up because I haven't got any guardrails around my workloads, and so the intern spun up thousands of dollars worth of infrastructure, and they didn't have to get approval, etc. You can put guardrails around things. Anomaly detection will help you detect if that happens. You can apply controls to stop those things happening to people that shouldn't be allowed to. So you can give playground accounts, etc. All of these things are covered in the FinOps. There's a really good FinOps book available as well. You can see it there on the finops.org if you go and have a look around the site. And overall, there's some great advice there. If you've got any questions around this and any follow-ups, then the team's going to hang around here for a little while so you can ask the questions directly. I love talking about this topic. It's one of my great passions. I'll finish here. I'll close out by saying that, remember, if it ain't broke, then you probably haven't deployed it into production yet. So there's that, because it always used to work on my laptop as a developer, so it's probably fine. Please do follow up with the looking at the slides. We'll share some further information on that. That will come out to you after this. Give you some bedtime reading tonight, and I look forward to meeting you all again in the future. Thank you very much.